Hey everybody, my name is Ian Yagelski, and I am a software quality engineer on the Edge SDK team. We make SDKs in a bunch of different languages that allow you to easily connect your remote device or edge device to ThingWorx and communicate with the platform and do all kinds of stuff. So this presentation is about testing your edge application, and we're going to be working mostly in C for the purposes of this presentation, but the practices I go over should be useful regardless of what language you're working in. So even if you're not a C developer, don't worry. So we're going to talk about unit and integration testing. We're going to talk about some test-driven development strategies and how that can enhance your development. And then we're going to demo a really simple edge application that we're going to develop using test-driven development to just build a really simple remote service and show you guys some of the new stuff that we have in our C SDK as well. All right, so let's get started. First of all, let's get some of the terminology out of the way. So unit and integration testing. What's a unit test? So the first question you probably should ask there is, what's a unit? And a unit is the smallest atomic piece of functional testable code that you can isolate in your program. So this is typically a function, right? Therefore stands that unit tests are just a set of tests designed to verify the expected behavior of that unit of code. And if you look on the right here, we have a really simple function is positive integer, returns true if x is greater than 0. So in this case, this would be our unit of code. And the three little tests underneath there that just assert that we get the proper return code back when we pass a negative, a positive, and 0 into that function are our unit tests, right? So a program is obviously made up of numerous units, hundreds, potentially thousands of different units. And the idea of unit testing is really to verify that each individual unit of code is functioning properly, right? But what about all these units working together? So that's where integration testing comes in. Integration tests combine multiple units together and verify that they coordinate and work together properly. So it's a much broader test. You're typically testing entire features when you're writing integration tests. And so we'll talk a little bit about why we test. So traditionally, the most obvious reason to test is to improve your software quality, identify defects, and prevent regressions, stuff like that. But one of the things I hope to go over today in this presentation is how that testing can really enhance your development and how you develop your code, as well as traditionally what we use testing for. So probably the most obvious way that tests can help you enhance your development is when you're debugging. There's a few things that are more useful than having a test that reliably reproduces the bug that you're trying to diagnose, right? So if you have a good unit or integration test that reproduces your bug just like that, you can run it, you can step through it in debugger, and you can find the source of the bug and squash it pretty easily. Another way that testing can really enhance your development strategies is through test-driven development, which is something that's become more and more popular as time goes on. So let's talk a little bit about test-driven development. So test-driven development is the idea of writing the test first and writing the code after the test. It sounds a little strange, but essentially you have your software requirements, and those translate directly into tests. And then you write the production code to pass the test, thus satisfying the requirement. So why would you want to do something crazy like that? Well, test-driven development encourages really good programming habits. So one of the things that test-driven development gets us is really modular and well-structured code. Your test serves as a roadmap, essentially. When you're writing your test, you're really laying out a roadmap for how your code should ideally function and be structured, right? You also get very stable code. I mean, obviously, the code is tested before it's even written, right? So well-tested, stable code. The code is also typically very clean and simple. As developers, I'm sure we've all been tempted sometimes when we're working on a task to complicate it or to touch things that we don't really need to touch to complete our task or satisfy a requirement. Well, the way that test-driven development really focuses you on passing the test and satisfying the software requirement, it really steers you away from needlessly complicating whatever it is you're working on. So we already talked about requirements focused and also well documented. So we'd all like to believe that when our customers unzip our SDKs, the first place they go is the docs and read all our documentation, but typically that's not the case. And I can't blame people. The first place I would go is usually working examples. And tests can serve as excellent working examples for your customers. And by the way, we ship all of our CSDK tests with our CSDK. So if you're looking for more examples than what are provided in the examples directory, you don't need to look any further than our tests. And we hope to be shipping them with our Java SDK and other SDKs as well soon in the future. All right, so we're going to do a really simple and quick example of test-driven development. So we have here a function called useless function, which is aptly named, and it will return foo. If you pass it a 0, it's going to return a bar if you pass it a 1 or 2, and it should return foo bar for any other input. So let's walk through the steps of test-driven development and see how we would develop this function using test-driven development. So step 1 is to add a test, and hopefully you guys can read the test when it pops up here. So let's add our test, and if you can't read that, essentially we're just passing 0 into useless function and asserting that we get foo back, which is precisely what our first requirement stipulates, right? So the next step is to run the tests. Obviously, our test is going to fail. That's kind of the point of test-driven development. We haven't written any code yet, so there's really nothing for our function to do. Step 3 is, unsurprisingly, to write the code. So we're going to write the code to pass this test. Pretty straightforward. If n is 0, we're going to return foo, right? Now we run our test again. This time the test passes. And the last step is to refactor or clean up our code. Then we just repeat from step 1 with our next requirement. So here's our next test that we assert that we get bar if we pass 1 or 2 into useless function. We run our tests. It fails once more since we haven't implemented the actual code to pass this test. Write the code. Here it is. If n is 1 or 2, we return bar. And we run our test. This time it passes once again. Refactor the code. This example is so simple, there's really nothing to clean up here, but normally you would go back through and make sure everything is neatly organized, right? And now for our last requirement, we'll add the test. We've returned foo bar for any other input. We're being a little lazy here and just testing the boundary conditions, but you could obviously take this test as far as you want to go. So we run our test, it fails once again. We write the code, there it is, return foo bar for any other input. Run the test, it passes, and refactor, and we're done. So now we have our software requirements, we have tests that are directly tied to our requirements, and we have nice, clean, concise code that is also tied to requirements. And we can prove that requirements are satisfied by these tests that we have developed as we were writing our code. So that's a very simple example, and in a little bit we're going to get to a more complicated example with a real edge application. All right, so before I get into that, I'm going to talk a little bit about the testing framework we use in our CSDK called Unity. This is from their website, throwtheswitch.org/Unity, and I'll just go over some of the features that they advertise on their website. So it's pure C, so it should run with virtually any C code base. It's very portable, should run on anything, any kind of small embedded device, whatever it is that your SDK or edge application is running on. Expressive, meaning they have plenty of assertions to test whatever it is you need to test in your code. Quick and simple, Unity compiles down to a simple binary. You run it, you get your test results, and you're done. And extensible, Unity also supports some extra stuff like CMOC, which is a mocking framework, but we're not going to get into any of that for this presentation. We're just going to keep things simple. All right, so let's get right into the demo. And I'm just going to swap over to my IDE over here. All right, hopefully everybody can see this. Is that readable? Everybody? All right, good. Okay, so what we have here is a very simple edge thing, and we're going to use test-driven development to implement a service for our edge thing, right? So I'm going to go through the source here line by line and explain some things we're doing. And while we're doing it, you can check out some of the new stuff that we have that we've implemented since CSDK 2.0. So this function right here, create simple edge app thing, is going to accept a string, a thing name, and it's going to first call twMakeThing, which creates the edge side thing. And just to clarify, we have an edge side thing that we create on the edge, and on the platform we have a thing on the ThingWorx platform that binds to that edge thing, so they work together as one, right? So this creates our thing, and we're passing in our thing name. We're just using a generic template for a thing. The next thing we're going to do is we're going to define a service for our thing, and again, this is a new syntax, and since CSDK 2.0, that makes things a lot easier. It used to be a real pain to do this kind of stuff, but now it's a real quality of life improvement. So here's our service. It's going to be called add numbers, and it's going to add two numbers together. There's our description. Next, we're going to define the data shape of our service input parameters. We're not going to name the shape here. We could optionally name our data shape, but it's not necessary for this example. So our two parameters are both numbers, A and B. Next, after we've defined our input parameter data shape, we're going to define our return type. In this case, that is a number as well. And we're just going to add A and B together and return another number. Since we're not returning no, that should be not. We're not returning an info table here, so we don't need to define a data shape for the result of the service. And the last thing we pass in here is a pointer to the actual function that will implement the service, add number service. And that's right down here, which is mysteriously unimplemented. So we'll be getting to that pretty soon. The last thing we do is we call twbind to bind our edge thing to the ThingWorx platform. This will essentially queue the bind to happen once we connect. So we call bind now, and then once we connect, we'll automatically bind everything that's been slated to bind to ThingWorx. And then right down here, we have our service. This is the actual function that will implement a remote service. We have 3 requirements for it here. The service will add 2 numbers together, A and B, and it will return the result, A plus B. It's going to return an error if no parameters are provided. And it's also going to return an error if either input parameter, A or B, is missing, right? Now let's take a look at the main function. And this is the main function that runs our tests. This is where Unity really comes in. We call Unity main here. We pass along our command line arguments. And we pass along a pointer to the function that will run our test groups. In this case, we just have one test group called simple edge app tests. Unity main will return the number of failed tests, so if everything went well, we return 0 success, right? All right, now let's take a look at the tests. And again, a lot of this is Unity syntax that we're going over here. So the first thing we do is we define our test group, simple edge app tests right here. Next, we define our setup function. This is the function that runs before each of our tests. So let's go through that. And I've collapsed these to make things more readable, but we'll expand them as we go through. So let's go over what we do in our setup here. The first thing we're going to do is configure logging. I have a little utility function here that disables logging just so we don't clog up our test result with logging from the CSDK. And the next thing we do is we initialize the CSDK API. So we call TWAPI initialize. I'm not going to go through each of the functions here, or each of the parameters here. If you want to look them, you can always check out our header files, which have, I know that's really tiny, but we have all the parameters laid out here. But suffice to say that we're connecting to a platform on my local host on port 8443. And we're going to assert that we get back TWOK, which is the success status for our initialization function, right? And just to show you, right over here, here is our platform side thing, where we have our service add numbers, right? Hopping back into the IDE. All right, so the next thing we're going to do is we're going to disable certificate validation. Don't do this in production. Really bad idea, but just for the purposes of running my local platform, I don't have a real certificate on here or anything, so we're just going to not validate the certificate. The next thing we do is we call our edge thing creation function. If you recall, this is the one that makes these 3 calls: make thing, define the service, and bind, right? And then finally, we connect to the ThingWorx platform. So we're going to call TWAPI connect right here. We're going to have a timeout of 5,000 milliseconds, 5 seconds, and 3 retries in case it doesn't connect the first time for some reason. Once again, we're going to assert that we get back a TWOK success status, excuse me. And then we're going to call TWAPI is connected and assert we get true, make sure we're connected. We're going to do the same thing with TWAPI is entity bound to make sure that our simple edge application has bound. And then we're going to start our CSDK threads. And that's going to spin up an API tasker thread that does some API tasks and a configurable number of message handler threads, in this case 5. All right, so next we have our teardown function. This is going to run after each test. And in reverse order, essentially here, we're going to stop our threads, make sure we get TWOK. We're going to disconnect from the ThingWorx platform. This is a reason that we provide when we disconnect. It'll show up in the ThingWorx logs. Again, we make sure we get TWOK. We check that is connected returns false. And then we delete the API with TWAPI delete. And again, we check TWOK. I could probably stop mentioning that every time it's there, but. All right, so the next thing we do is we define the test cases that will be run as part of this test group, the test group being simple edge app tests, right? So here are our tests. They're all commented out right now because normally in test-driven development you'd be writing these tests first, but in the interest of time I've already got them written and we're just going to step through them. So I'm going to on-comment the first one and we'll step through it. And as you can see, each of these tests corresponds with one of our software requirements, much like the much simpler example we went over in PowerPoint a couple minutes ago, right? So here's our first requirement. The service will add two numbers, A and B, and return the result, A plus B. And our plan here, our test plan, is to invoke the add number service to add the numbers 2 and 3 together, which should be 5, right, obviously. So let's expand this, and let's step through this test. All right, so the first thing we're doing here is we're declaring our variables. We're declaring an info table that will serve as the input parameters for our service. We're declaring another info table result, which will store the output info table of our service. And lastly, we're defining a double called value, and that's going to be the value that we pull out of the resulting info table, right? And that'll become more clear as we step through the rest of the test here. So the first thing we're going to do, let's see if I can get this whole thing on one. Yeah, there we go. All right, so the first thing we do is we create our input parameters info table. And again, this is all the new CSDK 2.0 macros. So we call twmake info table. We define our data shape for the info table. You'll notice this is the exact same data shape that we defined back when we defined our service right here. So we're providing a data shape that conforms to the parameters that our service expects. We've got two numbers, just like before, A and B. And we're going to add a row to the info table with the values for A and B. So that this number 2 right here is going to line up with A, and this number 3 is going to line up with B. So now we've got our parameters input table, info table created. The next thing we're going to do is actually invoke the service, right? So we're going to call TWAPI invoke service. We're invoking it on a thing. We're invoking on the thing called mySimpleEdgeApp, which is the edge app that we created up above. And we're invoking the add numbers service, right? We're passing in the input parameters that we just created. And we're also passing a pointer to the result info table where the result will be stored. We've got a timeout of 5 seconds once more. And this is a true-false Boolean flag that you can pass. If this were true, it would force the API to connect if we were already disconnected. But in this case, our setup function already has us connecting. So we're just going to do a no force connect here, which is defined to false. OK, so after we invoke our service and make sure we get TWOK back, we're going to verify the service results. So first, we're going to make sure that our result info table is not null. Then we're going to call TWInfoTable getNumber to pull the result field out and store it in our double value. Make sure that returns TWOK. And then we assert that the value we pulled out, that we stored in this variable value, is in fact 5, which is the result of 2 plus 3. I'm sure we're all aware. And lastly, we just call TWInfoTable delete to clean up the result info table, right? So if you remember the steps of test-driven development, the first thing we have to do here is run our tests. So let me make sure I commented this test back in. Yep. So we're going to run our tests. And let me zoom in down here. And unsurprisingly, our test has failed, right? We get a line number where the failure occurred. So right here on line 91, when we tried to pull the value number out of the resulting info table, we got an error 101, which is invalid parameter, right? So we were unable to pull that value out. We did not get TWOK, and we failed. So let's go and write the code to pass this test. So if we hop back over to our Edge service right here, where currently we're doing nothing but just returning success, I'm going to cheat a little bit and copy and paste so that I don't have to type everything in front of you guys and take up all your time. But we'll step over it line by line. All right, so the first thing we're going to do in our service is declare 3 doubles, A, B, and C. Once more, we're calling TWInfoTable getNumber to pull out the A and B parameters that get passed into our service up here. And we're storing those in the doubles A and B. We perform the calculation, C equals A plus B. And we return the results. We're going to call TWInfoTable create from number. And we're going to create an info table from this double C. and we're going to call the field that this value is stored in result. And you'll notice this is the same field name that we're trying to pull out over here. All right, if our content was not null, then we're going to return an error. Or if our content was null, rather, we'll return an error. Otherwise, everything was good, and we return success. So now let's run our test. And once more, I'll zoom in. You can see pretty concise output right there. Our test has passed now. So we've satisfied our first requirement of our software. All right, now let's go back and do the same thing with our next requirement. So here's requirement number 2. The service will return an error if no parameters are provided. So our test plan here is to invoke the add number service with null parameters. So if I expand this test and we step through it, you'll see it's a pretty simple test. We declare the result info table, as we did in the previous test. We're not going to declare the parameters info table because we're just going to pass null in. And we go right to invoking TW API invoke service. Right? So we're going to do it on our thing again, my simple edge app. We're calling the service add numbers. Here, instead of our parameters, we're passing in null, as the test plan stipulates. We're passing a pointer to our result, the timeout, the force connect, right? And we're making sure that we get back a TW internal server error. So we want to return an error here. We don't want to get TWOK. The last thing we do is we verify that this result info table stayed null, right? If our service fails, we shouldn't get any result back. So let me comment this test back in, and we're going to run it. We'll run both our tests, right? So you run the tests. Our first test passes, and our second test fails, right? So right here on line 109, so right here, we expected to get an error, but instead we returned success, right? Even though we didn't pass in any parameters, our service returned success, right? So let's go back and fix the code to satisfy this requirement. And the fix here is pretty simple. All we have to do, I'm just going to copy and paste one more time, is null check our parameters, right? So if our parameters are null, we're going to log an error, and then we're going to return an error, okay? So now that we've written the code, let's run the test one more time. And we get pass and pass. Okay, so that's 2 requirements down, 1 to go. So let's hop back over to our tests. I'm going to comment back in the last test. And if you recall, our final requirement is that the service will return an error if either input parameter, A or B, is missing. And our test plan here is to invoke the add number service once more with both A missing and then with B missing, right? Or whichever order I happen to do it here. All right, so let's step through. Once more, we're declaring our info tables for the input parameters and the output. And here we are once more creating the input parameter info table. As you can see, this time we only included A. We are missing the B parameter in this info table, right? And we're going to set A equal to 2. So there's our input parameters. And now when we pass this into our service right here, there's our parameters getting passed in, we should get an error because we're missing the B parameter, right? And once more, we're going to make sure that result stayed null. And then we're just going to do the same thing with B. So here again, we're creating our parameters. We're missing the A parameter. We're assigning the value of 3 to B. Then we're going to invoke the service one more time and make sure we get an error, right? And make sure that result stayed null. Okay, so let's run our tests, rather. So we got a pass, and a fail. So right here on line 137, we expect to get an error because we only passed in A. We didn't pass in the B parameter. But instead, we got success, right? So let's go back and fix the code to remedy this situation. So we were missing the B parameter, right? So I'm going to make a pretty obvious mistake here. And I am going to, this time when we call twinfo table get number, we're going to check the return code, as we should have in the first place, of that function call, and make sure if we didn't get TWOK, then something went wrong. We're going to log an error that the B parameter was missing, and then we're going to return an error. So now that we've addressed the error down here, let's run our test again. And the obvious mistake I made should probably pop up right here. Yep, so again, we still didn't pass our test. So let's see what happened here. So we got past this bit here. However, when we got down to here, where we only provided B and not A, This time we got a TWOK instead of an error in this case, right? So we forgot to check the return code of the other attempt to get the number out. So let's go back. I'm going to copy and paste one more time. And let's remember to check the return code of TW-info table get number when we're trying to pull A out as well. So now we're checking both return codes. If A or B is missing, we're going to log an error and return an error, right? So let's run our tests. And oh, I should have zoomed in here. And there we go, 3 passing tests. So we've got our software requirements. We have tests that prove that those software requirements have been met. And we have real nice clean code that's well thought out that handles all kinds of different failure cases that satisfies those requirements, right? And we can prove it does just by running these tests whenever we need to. All right, and that's it for our little demo here. I'm going to head back to the slides. All right, so let's just wrap up. The code that you just saw, by the way, will be uploaded online somewhere. I have yet to figure out where, but we're going to upload it. I'm sure you can find that somewhere around here. So we talked about what unit integration testing is, a little bit about why we do it. We talked about test-driven development, and hopefully you can see how test-driven development can really force you to have a real good focus on requirements and really prove that your software is satisfying those requirements, right? We showed off some of the new features of CSDK 2.0, or I think we're up to 2.1.2 at this point, but lots of new features and creating info tables that make things a whole lot easier. And once more, I'd like to mention that our tests, just like the ones that we just went through here, ship with the CSDK. So if you are looking for more examples or anything, just check out the test directory. Check out the test directory that we ship along with our CSDK. And all right, that's it. So, any questions? No questions? All right. Thank you guys for listening.